Hi everybody, I'm Val. I'm your TA for CE 574 Reactive Transport Modeling, and today I'll be recording a video on using the BioRT HBV Graphical User Interface, or GUI. So this is a very recent addition to the model, and it is meant to provide a convenient way to edit BioRT input parameters, run BioRT, and visualize the output of BioRT, all in a convenient program. But I do need to clarify, first of all, that this graphical user interface, or GUI, I'll be referring to it as a GUI, does not replace the BioRT program itself. So as you learned about in previous videos on input files you need to run BioRT, there's a certain file structure that BioRT adheres to. So in any folder of your choosing, you're going to put the biort.exe executable, which you should have downloaded from Canvas. Then inside that folder as well, you're going to create a new folder called input. Inside that folder named input, you're actually going to put another folder which contains your input files. So this file structure still holds for using the graphical user interface. However, the GUI can help you create some of these input files, modify some of these input files, and then ultimately run BioRT. But you do need to have this file structure specifically to run it. So I do want to emphasize that, that if you don't have this correctly, then it won't work. So also, just to recap, these 6 files are the files we need at the bare minimum to be able to run BioRT. And out of these files, these 3 files are needed to run the GUI program, because the GUI program and the BioRT program are separate. Okay, the BioRT program, which is over here, contains the calculations of the model, and the GUI code is just a program that visualizes a lot of BioRT's parameters and its outputs, as I'll be showing you later in the video. But basically, you need these 6 files to run BioRT, and you need these 3 files to run the graphical user interface. And the reason for that is this file, basically you can't make any of these files in the GUI itself. So this database file is super large and it contains information on all of your species. It is not recommended to make from scratch, and it's usually passed around by different users of the program. And these 2 files are from HBV, so obviously we can't make them using our program, but at the bare minimum, you're going to need these 3 files to open the graphical user interface. In addition, if you want to run BioRT in precipitation chemistry mode, which basically has variable chemistry for your input species in the precipitation that's entering the catchment, you are also going to need this precipchem.txt file. And it's also recommended to make this file outside of the graphical user interface, although the GUI can provide like a placeholder file for you to be able to run BioRT. If you're running in precipitation chemistry mode, you really should make this file using some other sort of software like Excel and using data from your catchment. And lastly, if you want to run in numerical experiment mode, which you're going to need these 2 files as well. And this numX, these are also recommended to make outside of the graphical user interface. So yeah, and you can make this numerical experiment precipchem file in the graphical user interface, but it's not recommended. So just to recap, these are all the files we need if we're going to run in precipitation chemistry and numerical experiment mode, which most of the time we are. And out of these files, the top 3 over here, soil.txt, chem.txt, and cine.txt, those are the most recommended to make in the GUI. So yes, that's what I want to go over before going before getting into how to actually run the GUI and how to navigate it. So again, we need these 3 files to run the GUI. So once you open the program, which is also on Canvas, you will see a screen that looks like this. So this screen is meant to help you select an input folder to open the GUI with. So if you click Browse, it'll open your File Explorer and you can select that folder. And just to clarify, this is not the folder named input that we talked about way back when we were talking about the file structure. This is not this folder. This is this folder, which is inside the folder named input. So you're going to select that folder, and this folder can either have files that are pre-made and have all their parameters inside of them already, or it can contain files that are only those 3 files that you need to open the GUI at the bare minimum, which is the database file and then those 2 files from HBV. And then you can make all the files you need to run BioRT inside the GUI from there. So one thing I do want to mention really quickly before I go into my demonstration about how to actually use the GUI is you'll see this checkbox on this screen as well, which says using version 1.0 of BioRT. So this is a version that was recently published by our group, and we will not be using it in this class. So just leave that unchecked. And if you check it, it'll cause issues with the input files we're giving you guys to use. So to be able to run those input files we're giving you on Canvas, just make sure that you don't check that box. But once you have your input folder selected, you can go ahead and click OK, and it will open the first screen of the GUI. All right, guys, so now it's time for a demonstration of how to use the GUI. So I'm here on my desktop and I have the program right here. So I'm going to go ahead and double click on that program. It does take a bit of time to come up on my computer, I've noticed. So I'm not sure if it will also take that long for you guys. It might be a good time to mention this, but this program is in development, and it's kind of like you guys are the guinea pigs for this program and seeing, what works, what doesn't, what do people find helpful inside the program, and what could be better about it. So at any point in the semester, if you guys have any feedback about this, please feel free to email me or talk to me about it. I would love to hear your thoughts. But yeah, there's definitely things that could be improved in this, so I don't want to claim by any means that this is perfect. It's just meant to help you guys and make, modeling a little bit easier. So like we talked about, this is the first screen that will come up for you guys when you open the program. Again, we're not checking this box in this class, so I'm going to go ahead and click Browse. And I'm going to navigate to where I have my input files. So like we talked about, this is my input folder. I'm going to go inside there and I'm going to open this folder named Sleepers. So once that's selected, I'm going to go ahead and press OK. And this is the screen that will come up for you guys. So I recognize this might be a little overwhelming, so let's go through it like piece by piece. So first of all, we know, so there's, as a broad overview, there's there's 2 tabs in this user interface. The first one is called Parameters and Species. The second is called Calibration. So the first tab is meant to is for you guys to create the soil.txt files and the chem.txt files. So over here, all of these parameters and options correspond to the soil file. And then here we have some of our chem parameters. And then right here, we have our primary, secondary species and minerals. So starting with soil, all of these boxes over here, they have the label for the parameter that you're editing. So one thing you'll notice is that these parameters came pre-filled. And that's because if I navigate to the sleepers folder on my desktop, you'll see that it has all of the files already made. So like you guys will have access to. So for example, the soil file over here, those parameters match the ones that are filled in this GUI. So what the GUI did is it extracted the parameters from pre-existing files. But so this is what you guys will be doing in this assignment is actually editing some of these parameters. The way you do that is you would edit this to say 30, and then you would click overwrite soil.txt. So now what this did is change the file itself. So now that passive water storage in the upper zone is no longer 100, but it is 30. So that's something that is important to mention is this program does edit those files permanently. It overwrites files, just like you would do if you were calibrating BioRT and editing those parameters manually. But once you overwrite a file, those parameters are lost. So it's recommended to either create a duplicate copy of your input folder so you have something saved with the original values, or just, be careful and don't overwrite something that you don't want overwritten. So all these parameters are editable. If you have a question on what any of these parameters are, you can click these question marks and it'll come up with a box telling you what that parameter represents. Similarly, in the chem file, or the chem parameters, we have all of the parameters that are familiar to you from the videos. Again, all of these are editable. One interesting or cool feature is, say you change this to 6 or anything you want. If you click revert chem parameters, it'll go back to what that value was before. This only works before you overwrite the file. So just, again, be careful. And then lastly, as you know, the chem file also has the names of all the primary species, secondary species, and minerals. So here, again, they came pre-filled because of the chem file for this input folder already had some species. So we have pH and we have our chloride. So over here, you can add or subtract any primary species. So for example, we already had 2 in the input files, but if we wanted to add a third one, like aluminum, for example, we would just add it like so, clicking the plus button, selecting from the drop-down list. You can also take it away if you want to. But if you add a new input species, primary species, and then you click overwrite chem.txt, you're going to come up with this screen. So for every primary species you select, you need to have a column in the precipitation chemistry file for that primary species. So the reason this warning is popping up is because our precipitation chemistry file looks like this. Where we only have a column for pH and chloride. So we're missing a column for our new aluminum species, so it said it's not found, and it asked for a value to input as a placeholder for every time step of the precipitation chemistry file. So in this case, I could just click cancel and it'll fill in every time step with 1E-10, but it's really not recommended to make format your precipitation chemistry file using this GUI. This is really just supposed to be a placeholder, and if you're using variable precipitation chemistry, it really should be coming from data from your catchment. So in this case, I'll just click cancel. It's also not found in the numerical experiment precipitation chemistry file, so I'll also click cancel. And what you can see is now our precipitation chemistry file has a column for aluminum. So in this case, I really don't want to have aluminum as a primary species, so I'm going to click the minus sign, and I'm going to click overwrite chem.txt. And now you can see that the precipitation chemistry file only has our two original input species as well. So that's just a broad overview of this screen. So again, this is for soil parameters over here. This is for chem parameters over here. And if you want to save the file, you can overwrite them. You can also, I forgot to mention, you can save a version of them with a custom name. So say I want a version of, I want to save these parameters in a file. So just in case I change anything and I forget what I changed it to, I have that original file. So I can save it under a name soil1, for example. And that will go in our input folder as soil1.txt. And it'll contain exactly the same content as our soil file. And this one will not be modified. So if I ever change the actual soil.txt file to something and I'm like, oh my gosh, what were those values? I have that file. So I would recommend making them just in case, just for calibration purposes. But yeah, those are our parameters on this screen. Our next screen is our calibration screen. So this has a few components. Over here on the left is where we can edit the concentrations of our different species. So for example, we have pH, we have chloride, and again, these values are pre-filled from the input files. So we had a cine.txt file in our input folder, so this is where those values were drawn from. So again, same thing applies here. So say I changed this to 6, and I want to change it back to 5.5. I can click revert, and it'll go back to 5.5. But as soon as we click this button, which says create cine.txt file and run BioRT, the cine.txt file will be permanently overwritten. So again, we have this button which you can save, which allows you to save a version of the cine.txt file with a custom name. So now that we have all of our parameters inputted, we can actually run BioRT. So you'll get this message that BioRT successfully finished running. Great, so nothing went wrong. So now the next step is actually visualizing the output of BioRT. So one thing you might have noticed is that this entire right-hand side of the GUI on the second tab is all about plotting. So we have our we have these two boxes over here. This is any species that we have observed data for. So there's a way of formatting this, which I won't go over in this video, but you can add, the program can pick up on data that you put in a specific folder, and you can use that data for calibration. But here are all the species that the model output actually generates. So for example, if you go back to our input folder over here, let's go back to, this is the folder where we have our BioRT executable. So now we have a new folder that arrived here called output. Inside that output folder, you have some output files. And these ones with numexp in them are the numerical experiment output files. And these results files are just are the non-numerical experiment output files. And you can see the most recent one, which we just ran, is over here. So if I double click on it, you can see that the model generated a time series of all of these species for every time step of the model. So that's what this drop-down menu is for. So let's say I wanted to visualize chloride in the river. I could click on this checkbox, and it will plot a time series of the chloride simulated output. So this output is only for a short time of the model, so you can use these arrows to navigate forwards and backwards in time. And you can see we have this original pulse of chloride, and it kind of settles down and then gradually decreases over time, just like we would expect. So if you wanted to plot discharge under that, you can use these checkboxes down here. So this is our simulated discharge, which the model draws from HBV, or the HBV file in the input folder. So you can plot that underneath this chloride time series, and you can see how they covary together. So you might notice that this peak every year coincides with a slight dip in the chloride concentrations. So yeah, but these two time series covary over the same period of time. You can also plot in log scale if you want, just in case your data has a really large range of values. You can display a CQ plot, which has the log of discharge on the x-axis and the log of concentration on the y-axis. Yeah, so those are almost all of the options you can do for plotting. So what you'll have to do in this homework is actually edit some of these parameters and see what the effect on chloride concentrations is. So in particular, you'll be editing this passive water storage in the upper and lower zone. So you'll be doubling some values given to you in the homework. So again, how you would do that? You would double these over here. You would overwrite the soil.txt file, and then you would go into this calibration tab, and then you would click create cine.txt file and run BioRT. That will rerun BioRT with the new updated input files in your folder, and it'll produce an output. So one thing that you might find useful for the homework is you can click these checkboxes over here, which will plot the previous output of BioRT. So before the last time you ran BioRT, before this time, that output will also show up on this plot. So that allows you to kind of compare between runs, which is also very helpful for calibration. So yeah, but I hope this was helpful for you guys, and please email me if you have any questions running the user interface, running BioRT, struggling with input files, and any suggestions on how to make it better or more useful. I appreciate all. So yeah, but I hope that was mostly helpful, not too confusing, and yeah, that's all I have.